How was the authoritative answer to the Monty Hall problem imagined? After several video productions, I have become increasingly aware of how cognitive illusions lead the Monty Hall problem astray. In this seemingly simple probability problem, there are actually three cognitive illusions that mislead the public. The first is the opportunity diagram most commonly used in authoritative explanations, the second is the two remaining doors after the guest's first choice, and the third is the superposition of possibilities after the process is repeated. Let's first look at the first illusion. The authoritative theory uses such a schematic diagram. For ordinary people, this picture is indeed very intuitive and suggestive. It is generally okay to say that this is a display of possibilities, but for rigorous mathematical problems, its flaw is that it does not define what possibilities are displayed. You can say that it is the possibility of combination, or the possibility of arrangement, or the possibility of facing a choice once, or the possibility of states that may appear in multiple games. But when calculating the probability specifically, the concept cannot be vague, because you must at least clarify the probability of which type of possibility to calculate. In a vague concept of possibility, the authoritative theory mixes the possibilities of permutation and combination with the repeated occurrence of states as the basis of analysis. Therefore, the conclusion is drawn that there are two chances to change the door. However, the actual situation is that before the guest makes a choice, no matter how many possibilities or what kind of possibilities are okay, but once a choice is made, the possibility is replaced by determinism. That is, in each game, only one possibility becomes the determinism of reality. See the schematic diagram, the possibility before the choice is frozen into the determinism of each game after the choice is made. The possibility schematic diagram before should be converted to the current determinism schematic diagram. The probability of the Monty Hall problem should be calculated based on the probability framework established by determinism, not based on the possibility caused by possibility. As long as a game cannot have multiple choice states at the same time, it is completely wrong to calculate multiple states into a single independent probability event. The second misconception is that choosing one of the two remaining doors after the first selection always gives twice the chance of the door initially chosen. In strict mathematical terms, the basic premise of having a 2/3 probability for a three-choice scenario relies on the target set of the chosen option having complete inclusivity. This means that all information can be accessed and displayed unconditionally, and the probability variables cannot overlap or be added to any probability space outside of the target set. The authoritative answer to the Monty Hall problem actually violates this fundamental premise. The so-called joint probability of the two remaining doors derives solely from a temporary virtual combination state. This combination is neither completely inclusive nor wholly independent of the outside probability variables. The guest's second selection, in reality, faces a new combination of two doors. Moreover, this combination has a chance probability of being exactly 1. The cognitive trap here arises from the language used to describe two goats as simply goats, which makes it easy for individuals without professional statistical expertise to overlook the fact that these two goats are not the same probability variable. If we call the two goats happy goat and joyful goat, then the host can face a combination of two doors that either have happy goat, joyful goat, or both. Each time a goat is revealed, it can only be one of them. The door selected by the guest naturally forms a new combination with the other goat. Additionally, according to the game setup, the host can always open a door with a goat when presented with any two doors. The information provided by this process can be limited only to the extent that the host reveals this inevitability. Any additional assumptions beyond this information border would violate the rigorous principles of scientific analysis. This is because the natural existence of the two-door combination is not defined by arbitrary differentiation. The following figure shows the complete status of the two-door combination in the Monty Hall problem. When there are two doors left after the first selection, the probability of each combination appearing is 1/3. Under the condition of only opening one door, no one can confirm which combination is currently present. The only thing that can be confirmed is that the probability of two goats appearing is 1/2 each. The revealed goat can provide a probability of a car combination of 1/3. Although the other goat that has not appeared also has a probability of a car combination of 1/3, its chance of appearing is already 1/2. Therefore, the probability it can contribute to having a car is 1/6. Adding these two probabilities together, we get that the probability of having a car in these two doors should be 1/2. If we analyze based on the guest's selected door and using the same logic, the probability of having a car in the guest's second selection is also 1/2. The calculation is not repeated here. However, under the continuous emphasis of the authoritative answer, most people not only accepted the magical proposition that the remaining two doors have a 2/3 probability of having a car but also treated this erroneous concept as a belief to uphold. Regardless of how one explains that the host does not make a random selection and that any two doors among the three can form three different combinations, those who believe in the authoritative answer are convinced that the two doors have a greater chance of having a car than one door. They will describe in various ways how two doors have a greater chance than one door. To avoid confusion in the narrative, we will not list those statements here. There is a shortcut to questioning the mistake, which is to use proof by contradiction. Because as long as it can be proven that a theory has an incorrect part, it is equivalent to proving that the theory is wrong. We know that there are three combinations of selecting 2 out of 3. So before the guest makes a choice, the host will face 3 two-door combinations. In these 3 combinations, there must be one where the 3 doors are A, B, and C. The guest chooses door B, and there happens to be a car behind it. In this situation, the host's opening one of the doors without a car is a random choice. He may open door A or door C. If the host opens door A, according to the authoritative theory, door C should have a 2/3 probability of having a car. If the host chooses door C, then door A should also have a 2/3 probability. Obviously, in this situation, the authoritative theory forms a self-contradictory paradox. According to basic knowledge of probability theory, the total probability of any set of possibilities cannot be greater than 1. However, in the above situation, the authoritative theory leads to the embarrassing result that the sum of the probabilities of having a car behind these two doors in the same state is greater than 1. Another place where illusions are produced is by making the arrangement of possibilities dynamic. Based on the first illusion of 2 doors, the authoritative theory follows suit and makes the possible arrangements of the 2 doors dynamic. The result is that the changes in the positions of the cars produced by different arrangements are overlaid with probability. Anyone with knowledge of analytic geometry can understand that a one-dimensional line and a two-dimensional plane have different mathematical properties. Even though the motion of a line can generate a two-dimensional plane, the properties possessed by the plane cannot be equated to those of a line segment. The probability collection of a lottery program is a one-dimensional state. That is, the possibility status of any probability point is only related to its other points of the same program, and it is unrelated to other programs. To make a vivid analogy, many people may know the principle of a music box, which is that a barrel with a specific convex arrangement rotates, continuously striking metal reeds with different pitches to play beautiful music. However, the premise for playing music is that the barrel must rotate. The scanners we use, and the movies, animations, and videos we see are based on similar principles. An undeniable fact is that static pictures of a single frame and dynamic pictures displayed sequentially over time express completely different information. The Monty Hall problem faces the same logic. It is understandable that under the induction of the triple thinking illusion, many people will fall into the trap of thinking illusion. I think, besides repeatedly explaining my reasoning, there is really no other way. Thank you for watching.